Hello everyone, my name is Sandeep. Welcome back to another session of BGP. I hope you all are doing good. So let's not spend much time and let's start beginning our session. So let's see what we have got today. In today's session, I'm going to cover load sharing with dual homed to dual ISP with multiple routers. The name looks complicated, but it is not so complicated. Let's understand what we have got here. So we have got Autonomous System 100 BGP. This is our customer edge network or our internal network. Okay, this is our internal network, and we have got two ISPs. This is ISP number one with Autonomous System 200, and we have got ISP number 2 with Autonomous System 300. Okay, and we are pairing from our internal routers, router 1 and router 2. We are forming iBGP neighbor here between router 1 and router 2, whereas this is my eBGP neighbor with my service provider. This is one more eBGP neighborship with my service provider, and let's say we have got um, one more autonomous system which is connected from service provider. Okay, so this is connected to the internet. You can consider that this is my internet, and these two service providers are again connecting to some third party service provider. Okay, so what we are going to see here today is that we have got some policies to apply, and we'll proceed with that. In my last video, what I had done is I had shown how to do a load sharing of BGP when you have two routers in your network and which are pairing with a service provider, a single service provider. In today's session, we have got two different service providers. We have two routers at my internal network, and we are going to pair with two different service providers. And let's see what we have got today. So as every service provider provides a default route, in our first task, what we will do is we will advertise a default route from Autonomous System 200. Okay, so let's advertise a default route here on router 1. This will be my first task. Also, I will be advertising a default route from router 4 to my router 2. Okay, so this will be my first task. Okay, so these two default routes are available here. Okay, and I've got two networks in my internal network, 11 as well as 12. So these are my internal networks which I will be advertising to service provider. Okay, so we will apply some policies here. Let's say how we gonna do a load sharing. Okay, so traffic destined to Autonomous System 200. So let's understand this. Let's say I have a computer here in a LAN segment, whether it could be 11 or 12 network. Okay, so any traffic that is destined to Autonomous System 200. So Autonomous System 200 is here, and I have got this network 200.0.0.0. Let's say my users wants to access this 200 network. Okay, so the source will be this whatever the IP subnet from our internal network, and the destination is 200 network. Then it should always use this path. This is my first requirement. The traffic destined to Autonomous System 200 goes through ISP 1, and traffic destined to 300 Autonomous System 300 should go from the second link. So in the Autonomous System 300, I have got this network 133.0.0.0. Okay, and in ISP 1 I have got 200.0.0.0. Okay, so if this user sitting in my internet network wants to access 133.0.0.1, then he should always go via this link. Okay, so let's draw it in a red color. Okay, if he wants to reach to Autonomous System 300, it will go via this link. Okay, so far this first point is clear, I hope. All other traffic should use ISP1 via default route. Okay, let's say I have this 155 network which is which has come to my router 1 and router 2, and let's say this user wants to access this 155 network. Okay, so this 155 network is not getting advertised here, right? But however, I have a default route coming from ISP A as well as ISP B. Okay, so whenever this user wants to access any other network apart from these two, let's say it could be 155, it could be 166, or any other network in the internet, then the traffic should always go via router 1. This is my third requirement. Okay, so we have got three requirements for the outgoing policy. Any traffic that is destined to this autonomous system should go via first link. Any traffic that is destined to second autonomous system should go via the second link. Okay, any traffic that is destined to any other autonomous system or any other third party, it should use a default route via ISP1. So these are the three requirements for the outgoing policy. We have got something on the inbound policy as well. Okay, so traffic from internet destined to 11000 should come from router 3 router 1 link, which means that any traffic, okay, any traffic coming from internet, either it could be coming from this or either it could be coming from this autonomous or it could be coming from here, it should always use this link. Okay, let me take a new screenshot. Okay, so what I was discussing was any traffic for 11 network, this network should come via this link. Let's say on the internet I have a computer sitting here and he wants to access this 11 network, then he should always use this link, R1 R3 link, or ISP1. Okay, similarly if he wants to access this 12 network, this PC here is sitting here and he want to access the 12 network, then the traffic should come via the second link. Okay, this is my second requirement. If one of this link fails, it should automatically fail over. Let's say this PC is trying to access 11 network and this link fails, right? So this PC should send the traffic via this link. Okay, this is our requirement. Okay, so let's get into more details of it. And before we start with the practicals, let's plan our strategy, how we are going to break this, and that would help us build our configurations quickly. So this is my strategy here. What I'm going to do to encounter or to fix this, to accomplish our task. Okay, so let me take one more. Okay, okay, so first thing what I would do is I will form a BGP neighborship between all these. Let's say for example iBGP neighborship I will form here. The eBGP neighbor I will form from here, router 1, router 3, eBGP I will form here, eBGP I will form here. The easiest task I will do first, right? So I will form a eBGP neighborship between these two. Then what I would do is I will advertise these two networks. This is again easy task. I will advertise 11 and 12 network via network command in the BGP on router 1 as well as on router 2, and this route should propagate up to router 5. Okay, so these two network, when I advertise in BGP in router 1 and router 2, it should receive on router 5, right? Then let's then what I would do is let I will fix the first problem, default route advertisement. That is the easier task. So what I will do is I will configure a single command, that is default information, and I will advertise a default route here. This is again the easiest task I will follow, right? So what I'm going to do is I will establish my BGP neighborship, and then I'm going to advertise the default routes. Then the trickiest part here is I want to do this outgoing policy and inbound policy, right? So we need to use the BGP attributes to accomplish this. Okay, so let's see. Okay, so here default information originate IBGP next hop, and these all things we will do. So for influencing the traffic, right? For influencing the traffic, what I will do is I have two options. So when this one is told that any traffic destined to autonomous system 200, right? So either we could do one thing, we could match the ACL, and we could add the prefixes, like for example 200. Any traffic that is destined to 200, I will create an ACL here, and I will tell that okay, any traffic, and I will permit this 200 network. Okay, and then I will use this ACL in route map to send the traffic via R1 R3 link. Okay, but what if we have multiple networks here, and we don't know what networks are being advertised from ISPs? So let's say this ISP is sending 201, 202, 203, 204, and so on. So we can't really go with this approach of creating ACL and matching all these IP addresses. So the other alternate way we have is by using regular expressions. Okay, so the simple regular expression is going to solve this problem. What we will do is we will configure a route map or ACL, in which I will do one thing. I will permit the traffic which is going to autonomous system 200. So the regular expression will be asterisk 200 and end. So whatever is permitted in the 200, okay, whatever route coming from autonomous system 200 will be allowed via router 1. So this is the trick we are going to use here. Instead of configuring all these routes in the prefix list or access list, what I will do is I will create a AS path access list, in which I will match this 200 AS path number. Okay, see here ACL AS path access list 1, and I will permit 200 autonomous system number. Okay, then for the incoming traffic, uh, right? So for the incoming traffic, what I'm going to do is I will use this ACL 200. Okay, and I will set a local preference to 200. I will hire the local preference for this link. Okay, so what I will do is, first thing, I created an ACL which tells that any routes with a with this 200 autonomous system, any route coming from ISP1, I matched, and then I called, then I set a local preference to 200 on router 1. Okay, anything coming from this ISP, I set a local preference of 200. Okay, the next point is, this is for incoming traffic. So I'm influencing my incoming traffic by this way. I'm configuring a local preference of 200. Okay, so let's say a same scenario, a user sitting here and he wants to access autonomous system 200 or this 200 network. The traffic should go via the traffic should always go via ISP A. The traffic should always prefer this path. Okay, so I have set an local preference of 200. Okay, let's say this traffic is going here on router 1. In the BGP table, he is going to take a look. Okay, the traffic is coming from autonomous system 200. The local preference is 200, so I'm going to send the traffic via this link. Okay, but what if this PC's traffic is coming to router 2, right? And let's say a destination IP address is 200, which is 200.0.0.1, and the packet has come to router 2. So what would happen is that he will check in the BGP table, and again the local preference will tell that okay, for the local preference is set to 200 for the router 1. So router 2 will decide that it should send the packet to router 1 for processing. So the packet comes to router 1 and he will again use the ISP A. So this is our incoming traffic policy uh, to make sure that ISP1 is preferred for this particular AS path. Similarly, what we will do is we will create one more route map and we will call autonomous system 300. Okay, so any traffic for autonomous system 300 we will define the same way here on router 2. So any traffic for which needs to reach to autonomous system 300, any traffic which needs to reach to autonomous system 300, he will go via this. This is our this is the task we need to accomplish, right? So for the inbound policy, what we need to do is for the inbound policy, this is done. For the inbound policy, what I will do is I will create one access list with 11 network and one access list with 12 network. Okay, I will permit both these. Okay, so if you look at my strategy here, I have configured an ACL. Okay, and I permitted these two. And what I will do is I will prepend the AS path, which means that if the traffic needs to, if anyone sitting here, let's say I have a computer here and he wants to reach to this 11 network, then the traffic should always come via this link. This is our requirement. So what I will do is I will prepend an AS path, higher AS path 100, 100, 100. Like this I will do. I will prepend this AS path for 11 network and I will advertise here. So when this route 11 network is coming to router 5, it has two entries. One via this link with autonomous system 100 in its AS path list, whereas one more whereas one more routing entry will have prepended AS path like 100, 100, 100 and so on, whatever we configured here. So when this computer wants to reach this 11 network, okay, the preferred way is via this first path, which tells that it should go via this link. And if this fails, it will have this secondary path available to send the traffic via this link. Okay, so this is how we are going to do or accomplish these two tasks. Okay, so start and let's start our configuration and let's not spend much time. Let's start our configuration. Okay, so let me jump on quickly to the configuration part. I have router 1, so let's see what I have configured here. To save some time, I have configured um, the BGP and IP addresses. So running section BGP, I will show you what configurations I have done so far. Okay, I'm on a router 1. And okay, I'm on a router 1 here and I've configured BGP with 13.3 and I see iBGP also configured here. Let's quickly verify. Show IP BGP summary. Okay, and both the links are up. I mean both the BGPs are up. Okay, so let's quickly verify router 2. Is the BGP up? Show IP BGP summary. Okay, looks like the BGP is up on router 2 as well. So router 3 and 4 no need to verify. I'll jump onto router 5. Show IP BGP summary, and I see that the BGP is up. So as per my task, what I will do is I will advertise these two networks 11 and 12 into router 1 and router 2. Let's do that quickly because I have verified I'm not advertising any route. Let me show you again. Show running section BGP. There are no routes advertised here, and I will quickly verify if I have configured these IP addresses. I have 11. Show running interface f80/1. For the simplicity, what I have done is I have configured two IP addresses on a same interface so that I can easily advertise this network. So 11 I have configured as a primary and 12 network I have configured as a secondary. So on a router 1 conf t router BGP 100, and I will advertise these two network. Let me advertise this quickly. 100.0.0.0 mask 255.255.255.0, and I will advertise this second network. Okay, and similarly I will do the same steps on router 2. So these two networks I have advertised. Let me go to router 2, and I'm going to copy paste the same thing. Okay, so I'm advertising this router, the route from router 1 and router 2. So this route should get propagated to router 5. It is going to take some time as BGP is slow protocol. I don't see it here. Let's give some time. Okay, so the routes are learned here, 11 and 12. Okay, so this looks good. The first thing what we did is we advertised this 11 and 12 network here, and these routes are seen here. So we are good with this. Let's do this one. AS200 as well as AS300 should advertise a default route from here. So we should advertise this default route. So let's quickly verify router 1 doesn't have any default route, and router 2 also doesn't have any default route. I'll do show IP route. You see here we don't have any default route. Let me quickly verify show IP route on router 2, and you see here you don't have any default route. So what I will do is I will quickly jump on to router 3 and configure a default route. Show running section BGP. Okay, so I've got a neighbor conf t router BGP 200. Which neighbor I should apply is I should apply this on router between router 1 and 3. So this is my neighbor. The command is straightforward, default originate. Okay, so I'm advertising a route from router 3, and I'll do the verification on router 1. Show IP route, and I should see a default route coming from BGP. See here. Okay, similarly I will do on router 4. Show running section BGP I'll do just to make sure which neighbor I should advertise. Conf t router BGP 300 I have, and then I have neighbor. This is the neighbor 10.1.24. So this neighbor I should advertise. I see there's one more network 24.2. This is misconfigured, or this one is misconfigured. 24.2 default originate. So I'll verify on router 2. So IP route. Okay, so I see that the default route is coming here. So this step is done. The next step is to do all these route maps. So let's start doing for start doing the part for incoming traffic. So what we need to do is that any incoming traffic, which means that um, which means that if I'm sitting here, if I'm sitting here, and if I want to reach 200 network, right? So I should send the traffic via this link. So this part we will cover first. Okay, so what we will do is I will configure an AS path access list. See here my strategy on the router 1. Let's start with router 1. Conf t IP AS path access list. Let's give access list number 1, and if you see here it's permit. So here you could see a regular expression. Okay, so regular expression is begin with 200 and ends here. Okay, so I'll verify this. Do show IP AS path and show IP AS path access list. Okay, you could see that I have AS path access list 1, which is telling that permit 200, which means that anything in the anything destined to this particular autonomous system number, it is permitting. Okay, so this is done. So I'll configure a route map for incoming traffic on router 1. The route map, any traffic, I'll give this name incoming hyphen incoming from AS200, right? So I'll give this name permit 10. Okay, and I'll do match AS path access list. So I need to give AS path access list 1 here, and I'll set a local preference. Local preference I'll do 200. Okay, so far what I've done is I created an ACL AS path ACL which tells that match 200. Any traffic coming from this 200 autonomous system, I created one ACL, and then I created one route map in which I am telling that any traffic which is going to this destination 200, or any traffic that is destined to autonomous system 200, it should set a local preference of 200. Okay, which means that if someone is from my local network is trying to reach to this 200 subnet or 200 AS path, I set a local preference of 200. Okay, so local preference is set here, correct? So what I will do is this is done. Then I'll create one more route map for outgoing traffic, or let's do this. Um, okay, so similarly, I'll configure the second route map for outgoing traffic. So I'll configure on the router one first. Route map outgoing permit 10. Okay, before this I should have configured two ACLs. I'll do one thing. IP access list 10 permit access list. I'll use a standard ACL access list 10 permit my first network is 11.0.0.0. Mask is, sorry, our wildcard mask is 0.0.0.255. Similarly, 11 and 12 are my network, inside network. I have created a simple ACL to match 11 and 12. Let me just show you here. So I've created two ACLs to match 11 and 12. To match 11 and 12 network. Okay. So the next thing what I will do is I will create a route map and I will use this route. I will prepend one of the network. Route map outgoing permit 10. And what I will do is see what I need to do is it should always prefer this link for 11 network, correct? So I will not prepend on 11, I will prepend on 12 network. Okay, so 12 I have used access list 20. For 12 network I have used access list 20. So what I will do is match match IP address access list number 10, sorry, access list number 20, and set AS path prepend 100 100 100 100. Okay, I'll do exit and I will create one more statement to permit any other traffic. Match IP address 10. Okay, so this is my ACL AS path prepend. Okay, and now what I will do is I will apply these two route maps to the neighbor. Show running section BGP router BGP 100. I need to apply this to neighbor 10.1.13.3. So this one outgoing I will apply in out direction. Route map, I'm applying the route map in out direction. Similarly, I will do neighbor 10.1.13.3 route map. My route map name was incoming. What was my route map name? Okay, incoming autonomous system 200, and I will configure this as in indirection. Okay, so this is done so far. Show IP, show running section BGP. You could quickly verify the two route maps I have applied. I will follow the same approach in router 2 as well. So what I had done is first I had configured AS path access list, AS path access list 1 permit IP AS path access list 1 permit. This time I will do what? I will do asterisk asterisk what is this autonomous system number here? 200 300. Okay, 300 I will permit here. Okay, and I will configure route map. Route map I will give it as this is for incoming traffic. So incoming from autonomous system 300 permit 10. And what I will do is I will call this AS path match AS path access list, right? AS path is path access list 1. Okay, and I will set a local preference of 100, 150. Did I do the same thing on router 1? Did I configure the local preference or no? I believe I have not done that. Okay, so let's do that. Let's quickly verify. Let's quickly verify this route map on router 1. Show route map. This is a big route map. Okay, route map AS200. Okay, I had done this. I had set the local preference. I thought I have not done. Let me jump here. Set local preference 150. This is done. Okay, so the second route map for outgoing traffic, what I'll do is IP access list or access list 10 permit 11.0.0.0 and mask is 0000255, access list 20. I have configured these to access list 10 and 20. Okay, and now I will do a route map. This is for outgoing traffic, permit 10 for example, match IP address. Okay, let's take a look what we are doing here on router 2. On router 2 we need to prefer 12 network, which means that if someone's sitting here and if he's accessing the 12 network, then he should come via this link. This is our requirement. So AS prepending will should be done for 11 subnet. Okay, so I will call access list 10 here. Set AS path prepend 100 100 100. So 300 I'll do. This is done. There's one more entry I need to add. Outgoing 20 match IP address 20. Okay, I believe I have done with the configuration, except I need to apply this onto the BGP neighbor. Conf t router BGP 100 and neighbor 10.124.4, and then I'm going to apply this outgoing. I will apply it as out. I'm missing a route map, my bad. Route map. And similarly I'm going to apply the incoming route map in direction. So what was my route map name? Incoming hyphen 300 AS 300 and in the in direction. Okay, show IP. Let's verify quickly. Show running section BGP that I'm not missing anything. If I make any mistakes here, our verification will not be successful. So let's so far I've configured everything, and now it's a time for verification. Okay, so let's do our verification. Now for the verification, here is my strategy. Let's do a verification on router 1. The first verification is show IP BGP. Very straightforward. Verify that the default route should be preferred by ISP A. Okay, on a router 1, show IP BGP. Okay, so I'll maximize this for understanding. Okay, so I've got this default route 00000, show IP BGP 0000, and I have two available paths and both are best, and the valid path is via 13.3. Okay, the valid path is external and it's via 13.3, which means that the default route on this one is always preferring 13.3, right? So this is our first check and this is what we wanted to do. Okay, all other traffic should use ISP1 via default route. Okay, so if I want to reach to 155 network, I should always use this default route. Okay, and this default route will be used to send the traffic to this guy. Okay, so let's let's proceed with our verification. Anyhow, I will add this route here on router 5. I think I'm missing that. Show IP interface brief. Okay, 155 is configured here, but am I really advertising? Let's verify. Conf t router BGP 400 network 155.155.0.0 mask 255.255.255.0, and I'm advertising this network here, and my router 1 should receive this network as well. Show IP BGP, still not propagated. It's gonna take some time. Okay, let's give some time for that to come here. Let's proceed with our next verification. Show IP BGP on router 1. Let's do that. Also notice that routes coming from ISP A and B. ISP A should have local preference of 200, ISP B should have local preference of 150. Okay, so what I need to do is I need to notice the routes coming from ISP A and B. So in my diagram, I should see 200 network here on router 1. Also, I should see 133 network. I believe I'm not advertising these networks too, so I need to advertise these networks. So I'll jump onto router 3 and advertise it. Show IP interface brief. Let's verify if I have that. And conf t router BGP 200 network 200.0.0.0 mask. Okay, I have advertised 200 network in my topology. 200 network I advertise here, and I will advertise 133 on router 4. Conf t router BGP 300 network 33000 mask 255.255.255.0. Okay, I should see this network here from router 4 to router 2. Show IP route. Okay, 200 has come and 133 has come. So similarly, I should see the same thing. Both the routes I should observe here. Okay, 200 and 133 has reached here. So that's a good sign. So let's, as per our topology, we should do a verification of show IP BGP, and we should notice that routes coming from ISP A and B, these are coming. 200 is coming from ISP A and 133 is coming from ISP B. ISP A should have a local preference of 200. ISP A should have a local preference of 200, which is good. ISP B has a local preference of 150. Okay, so ISP A has local preference of 200 here, and ISP B has a local preference of 150. So similarly, if you verify that on router 2, you'll you should see the same thing. So if a traffic coming from any PC and he wants to reach to autonomous system 200, it will go via this link. Okay, so this is one more verification. The next verification I need to do on router 5. Next verification I need to do on router 5. I need to see that 11 and 12 is being advertised here, and as per our plan, traffic from internet destined to 11 should prefer R3 R1. So if I'm sitting here and if I do show IP route for this 11 network, it should go at this link. So let me jump onto router 5. I see show IP route, 11 network is here and 12 network is here. So what I'll do is show IP BGP I'll do. For 11 network, you could see that the next hop is 35.3. For the 11 network, this is the 11 network, the next hop is 10.1.35.3. So for the 11 network, the traffic is going via this link. For 12 network, the traffic should come via this link. So I should see the next hop as 10.1.45. You could see that the next hop is 10.1.45. So far we are good. Okay, so far we are good here. We have done this verification. Okay, now the last step, what we want to do is failover scenario, and if we find that this is working, then we should be good with this configuration. So failover verification. On the router 1, I will shut down this interface. Okay, I will shut down this interface, and the traffic should go via this. I mean, at present the traffic is going via router 1 to reach this 155 network, or to reach this 200 network. Okay, so when I shut down this link, it should go via this alternate path. Okay, so let's quickly verify that. Okay, so I'm on a router 4, and on a router 1, as per our plan, the traffic to 200 network should go via this link. So let me verify that. I'm doing a trace route on router 1, and it is going via 10.1.13.3, which is this link. Okay, similarly, let's verify from the router 2. Router 2 should also take this path to reach 200 network, because we have configured it such a way that it should always use this link, R1 R3 link, or ISP-A, to reach this 200 network. So let's jump on to router 2. I did a trace route, and the trace route is not working. There's some problem with our network, so let's do show IP route. Okay, so show IP route shows that 200 network is reachable via 10.1.13.3. If you take a look, that I'm here on router 2, and it is showing that the next hop is 10.1.13.3, which is this IP address. So there is a configuration problem in my BGP, and if you're guessing that I have not updated the next hop self, then you are right. So I need to do a next hop self here on this router, so that, as well as on this router. So let me just quickly do that on router 1. Show running section BGP. Okay, conf t router BGP 100, and my internal network is this one, Next hop self. Similarly, I'll do the same thing here. Show running section BGP. Conf router BGP 200. Oh, all right. Router BGP 100. And next hop self. Let's see if this has fixed our problem. On router 2, show IP route I will do. See, this is changed. Earlier it was showing that router 3's IP address. If you notice here, now it is showing router 1 from router that is 11.0.0.1. If you take a look, earlier it was showing as 10.1.13.3. So that should fix our problem. Okay, and that's it. So from router 2, my verification from router 2 is that I'm trying to reach this 200 network and the traffic is going via this link. Okay, so this is the verification we wanted to do. Traffic destined to autonomous system 200 should go from ISP 1 and traffic destined to autonomous system 300 should go via ISP 2. So for 300 network I will use 133 verification from router 2 trace 133.0.0.1, and that's right. I'll go back to this topology from router 2. This is my autonomous system 300. I will use this link. I'm doing a trace from router 2 and it is using this. Similarly, if I do a trace from router 1, it should go via this link. This is what we wanted. Traffic destined to autonomous system 300 takes ISP2. Let's do a quick verification from router 1. Show IP route. We should see 133 here and then a trace route. Okay, so that's working. You could see that from router 1 the packet has gone to router 2 and from here. So our next verification was all other traffic should use ISP1. So all other traffic is nothing but 155 network. So let's quickly check 155.155.0.0.1 whether it's going via this link or it's going via this link. As per our requirement, it should go via ISP1. So from router 2, I'll do a verification. But for some reason, I'm not seeing the route here. So it should prefer the default route because you see that 155 network is not shown here. 155.155.0.1. If I do a trace, it's going up to router 3. It's going up to where I am. Okay, I'm on router 1 and I'm doing a trace to this network and it's going via 10.1.13.3, 10.1.13.3, 10.1.13.3. So it is correct. Similarly, we will do a verification from router 2. Similarly, we will do a verification from router 2. This could be any network. It's not reachable for now, but that's fine. We wanted to verify that any other traffic, okay, it could be 2201 or any other traffic from the internet, for example 200.0.0.1 or 55 55 55 55. Okay, this should also go via this link. Okay, and that's working because it's going via router 1. Similarly, I'll do this same thing. Trace route any network should go via ISP1, but that's not happening here because show IP BGP. Okay, I think that should be fine. So let's verify by shutting down the let's verify our failure scenario. Let's shut down the R1 link. Conf T interface FA 0/0. I'll do a shutdown here on this link. Okay, So the router 1 ISP is down now. So the router 1 ISP is down here. And now, any traffic from router 1 should use this link. So if I do a trace route to 200 network, it should still be reachable via this path. Okay, so let's do if that's working or no. On router 1, I should see a show IP route. 200 is missing here. Trace route. It's not going to work because it's showing a default route. Point it to router 2. It should work. Router 2. I think it's taking a time for convergence. 200 network is still not propagated here. I don't see here. I should get a 200 network here. It's gonna take some time. So let's do a quick verification. On router 1, default route should be via through ISP B. See, show IP route. On a router 1, it has quickly changed to ISP B. So I'm getting the route from ISP B. Earlier it was ISP A. See here, ISP A. When the link is down, it is showing it's ISP B. So this verifies this verification looks good. Show IP BGP. Similarly, we can do a show IP BGP on router 2. Default route shows it's via ISPB 24.4. And the last verification is I need to jump onto this last router 5, and verify these two networks via the secondary link. Earlier 11 was showing as ISP A, which is this way, 35 10.1.35. Now it should show that 10.1.45 for both the networks. So on a router 5, see, this 11 is showing as 10.1.45 and 12 as well showing as 10.1.45. Whereas I'll compare this with my earlier output. 11 was showing as 35 and 12 was showing as 45, which means that 11 network was showing as ISP A and 12 was showing as ISP B. Now it's showing as both are showing as ISP B because ISP is not reachable now because I've shut it down the interface there. Okay, I hope that is good for now. Okay, so the last verification what I wanted to do is that I want to reach this 200 network from router 2, and it should go via this link this way because this is down at the moment. And trace route, it's working fine. So this concludes our lab today, and we have done all the verifications. And if you like this video, click on like button and subscribe my channel to see more videos. I would like to thank you for watching and spending some time. Have a good learning, good weekend, good day. Thank you. Bye.